Okay, भाई, what did you do yesterday? चलो कभी देते हैं. Hmm. We did Rutherford's model basically. Rutherford's model which had how many points? 6 points basically. Any doubt? Hmm. So we did scattering experiment. Three conclusions which are direct, which give us the nuclear model of atom, which is atom is what? Mostly empty. There is a positively charged nucleus which is concentrated mass, not uniformly distribute, and electrons and protons are held together by electrostatic force. Then we can find the size of the atom, which is 10 raised to the power minus 10 meter. We can find the, what can we find? Size of nucleus by closest distance of approach, and a general formula which is R is equal to R naught a to the power 1 by 3. This is atomic mass or mass number, and this is 4 by 3 into constant 4 by 3 into 10 raised to the 1 minus 30 centimeter or 50 meter. And the last thing is number of alpha particle scattered at angle theta, which is proportional to 1 upon sine to the power 4 theta by 2. Okay. Then we started talking about atomic mass, atomic number. What is A? A is n plus p, Z is p. And in mass, we are not counting electron because electron mass is negligible in comparison to the mass of neutron and proton, right? 1837 times. So if a, okay, now based on this, we have relationships. What relationships do we have? Isotopes. What are isotopes? And then we have isobars, which are same mass number. What can we say about chemical and physical properties of isotopes and isobars? Isotopes same with different physical properties, and isobars different chemical properties. And isotopes are going to be of same element. That's needless to say. Isotopes are going to be of same element, while isobars are going to be of different elements. Clear? Next is isotones. What is isotones? Same number of neutrons. Okay. Isotones are same number of neutrons. How do you get how do you calculate neutrons? How do you get number of neutrons? You get number of neutrons by A minus Z. So A minus Z value for whichever set of elements is same, those set of elements you can classify as isotones. Okay, clear? Next is isodiaphers. What do they have common? A minus 2Z. What does that mean? What is A minus 2Z? A is what? Mass n, which is n plus p minus 2p. Can I say that? So what do they have common? The neutrons and protons, which is also known as where is it? Not written anywhere. This is known as written somewhere. Yeah, isotopic excess. So if n plus p is same, they are isobars. If n minus p is same, they are known as isodiaphers. You can take this example for it. Let's do this. So for U, we talk about A minus 2Z. What will that be? That will be 235 minus 2 into 92, which will be how much? How much is that? How much is this? 16 and 35, 51. And you do the same thing for thorium. 231 minus 2 into 90. 231 minus 1 into. Okay, done. Next we have isosters. So isosters are two criteria: same number of atoms, same number of electrons. Anything that follows that, there will be isosters. Okay. So you can take N2 NCO. For example, how many atoms in N2? 2. How many atoms in CO? 2. How many total electrons in N2? 14. How many total electrons in CO? 14. Okay. So same number of atoms, same number of electrons, they are called isosters. Again, you can take this. This is how many? 18. This is how many? 18. How many atoms? 2. 2. So both conditions have to be satisfied. This is not B6 and 6. This should be B3 and 3H6. Inorganic guarantee. Then this is B3N3H. You know benzene? You know benzene? This is benzene. Each of has hydrogen atom. This is inorganic benzene. This is inorganic benzene, also called borazole or borazine, because this is inorganic molecules but similar to this. Okay. And the last thing is isoelectronic species, which is what? Same number of electrons. Okay. Okay. Did we answer? See? 1h1, 1h2, 1h3, neutrons, 0, 1, 2, total sum is mass number of X will be, this will be, what are the relations between them? There are iso, iso, है ना? Correct. This is 6 C12. Hmm? 5. Okay. Everybody getting 5? Any other number? Let's check. This is 10, this is 10, this is 13, this is 10, this is 10, this is 7, this is 12, this is 10, this is 11. Clear? B, C. What is the answer? Huh? Hmm. 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 Okay. We'll come to this later. Let's first talk about average atomic. And this has larger implications as well. We'll talk about that also. So first is average atomic mass. So like now chlorine has two isotopes. Let's say this exists 75%, this exists 25%. Now what is the mass of chlorine do we take? We take 37, we take 35, what do we take? So we can find the average atomic mass and take that based on percentage composition. So mass of chlorine would be actually how much? So let's call this value M1 and this series X1. Let's call this M2. This will let's call this X2. m1 x1 plus m2 x2 divided by x is what? Constantly composition. Or mole भी हो सकता है, whatever. You can take pretty much anything. And m is what? Now what are the larger? Okay, sorry. Now there are other applications of this as well. For example, somebody says, I want to find the mass of air. How do you do? You can use this, no? So there's certain amount of nitrogen in it, certain amount of oxygen in it, certain amount of carbon dioxide. Just multiply with the masses, divide by total, you will get mass of air, right? So like that you can not just for isotopes to find atomic mass, you can apply this concept pretty much everywhere. You have a bunch of stuff and you're trying to calculate average mass. Okay? Yeah. चलो ठीक है. Now there is an interesting change in the history lesson that we have been doing. So what is the name of the chapter by? Structure of atom. What are we studying? Structure of atom. है ना? We start with older people and then we start with in modern times with Dalton. Okay, the first theory of atom. Sorry. Then we talk about Thomson, anode rays, cathode rays, discovery of charged particles, plum pudding model. Then from that the next model, which is the nuclear model. And now all of a sudden we will start studying about waves, which doesn't make any sense. We should continue studying atomic model. So that's why I call it a twist in the tail. So now we will talk about waves for a while, and hopefully by that time we are done talking about waves, we will understand why in structure of atom all of a sudden we pivoted and started talking about waves. Okay, keep an eye out. Now we change our story and talk about waves. So waves, I think you guys are familiar with. What is waves? How do you define what is the definition of a wave? Huh? It is, but what is the fundamental characteristic that defines a wave? Energy without moving matter, without transfer of matter. That is what a wave is. Absolutely. This is the key part. Transferring energy without actual movement of matter. That's the fundamental quality of a wave. अच्छा ये लिखा हुआ है सामने लिखा Okay. Now about waves, certain properties, fundamental definitions. You need to understand what are those definitions. Wavelength, wave number, frequency, amplitude, and velocity. Okay. So one by one we can talk about these things. What is wavelength? So this is a wave. It is the distance between two consecutive or second. Wait, let's go through the ones. Write all at once. Second is wave number. What is wave number? How do you define? How do you understand wave number? The number of waves in 1 meter, basically. Very simple. Okay. What counts as one wave? The periodic oscillation will count as one wave. So this, the repeated unit, है ना? That will count as one wave, and the number of waves in 1 meter will be wave number. Clear? Then next is frequency. Number of waves passing through any given point in 1 second. That will be frequency. Amplitude is the height of the crest or so, and velocity is distance traveled by wave per unit time. Clear? Oh, done. Relationship between velocity, wavelength, and frequency of wave. What is the relationship? Relationship is C is equal to, or V is equal to into lambda. For electromagnetic radiation that we will deal with, velocity is equal to, we will talk about electromagnetic radiation for linear, V is equal to C, so C will be equal to frequency into lambda. Okay. The options are not correct because they don't have frequency. So write the question. Write the question. What is the value of frequency? Hmm? Solve it. Hmm? Hmm. So किलो से स्टार्ट करते हैं. किलो, हेक्टो, डेका, मीटर, डेसी, सेंटी, मिली, माइक्रो, नैनो. And there is one more unit called angstrom, which is how much? 10 to the power minus 10 meter. Okay. What is the frequency, guys? The first you have to find wave number. What is the wave number? Which option is the answer? So lambda will be equal to 1 upon wave number will be equal to 1 upon lambda, which is 1.7 into 10 to the power, which is option A. What will be frequency? Frequency will be 5.10 to the power 14. Everybody is getting this only? The frequency should be C by lambda. C is 3 into 10 to the power 8 meter per second. Always write units. That's where most errors happen. Lambda is what? 580. So how much was it? 580 nanometer? Huh? 3000 into 10 to the power 5 plus 9 divided by 580. 300 by 58 into 10 to the power 14. 5 point 5.17, correct. Clear? Very straightforward. Remember is the unit of. Hmm. Now let's talk about electromagnetic radiation. So we talked about this a little bit before, right? We talked about this when we were doing what? We talked about the drawbacks of nuclear model of atom. So the problem comes from कि भाई if there is a we said कि भाई there is Maxwell he said a point कि if there is a charged particle which is under acceleration then it will radiate electromagnetic radiation है ना. So how does it, so what is the Maxwell theory? Now we come to that. So the Maxwell theory is, as we said, there is a charged particle which is under acceleration, and when it is under acceleration it will there is a direction of propagation it will have, the direction in which it is moving, and the direction in which it is moving, it will produce electric and magnetic field which are perpendicular to the direction of propagation as well as perpendicular to each other. So if your direction of propagation is x, then electric field is generating in y and magnetic field is generating in z, right? So all these three things are mutually perpendicular to each other. So 2 points, just 1 minute. For 2 points, what is the first point? If a charged particle is under acceleration, it will produce waves. What kind of waves? Electromagnetic waves. What does that mean? There will be electric field, there will be magnetic field. What is the direction of that electric magnetic field? Perpendicular to each other and perpendicular to the direction of propagation. Clear? Okay. So these are the properties. As I said, first point, electric magnetic field perpendicular to each other as well as perpendicular to the direction of propagation. Second, they don't need medium. This we already know. They don't need medium. They can travel anywhere. Velocity as light, as I said, is 3 into 10 to the power 8. This is a very important point. This will really change human history. It should be very clear to you. Energy of EMR is directly proportional to intensity and independent of frequency. What are they saying? What is intensity in real life? How can we translate real intensity to in real life? Intensity is what? Brightness, right? So what are they saying? What are we saying? If you have a wave, if this bulb is there or anything, if you increase the uh, energy of whatever is providing, what will happen? The brightness will increase, right? Intensity will increase. It's not like if you give this now more energy, it will become. How can you wait? Okay, let's talk about both. Intensity is like brightness. If intensity is brightness, then what is frequency? How can you understand frequency in physical world? It's different colors, right? Different colors are different frequency. Yes, that's fair. So if I increase like provide this more energy, what will happen? This will become blue color or this will become just brighter? This will become brighter, right? Make sense? We will come to this and we will see contradictions in this, which literally change everything. Everybody understands this point clearly? I'm asking again and again, bhai. Yes, we'll talk about intensity as well. Actually, we have started the second chapter. There's a first chapter in which actually if you actually you should read that part in NCRT. There's everything unit related to units and measurements is given there. All these nanometers. There is a book, no? This part two. How come part two is so thin? What? Huh? Acha, they have removed the P block, okay, from this. No. They have removed the inorganic chemistry part from this actually. Hydrogen is not there, P block is not there. Yeah, actually, so I will tell you, and this is your homework for today actually. This is page 1, 2, 3. This is the unit just we talked about. So let's say till here. Uh, yes. Page number 60. I'll give you homework. Okay, bhai. So this is again just to illuminate the point that if this is your direction, then direction of magnetic field is perpendicular to that, and the direction of electric field will be perpendicular to both of them. Clear? Again, this direction, this direction, this direction, like this. What is the direction of electromagnetic wave? Perpendicular to each other. Is there any need of medium for propagation of electromagnetic wave? No. This you need to learn. Yes, you need to remember it. They will ask you specifically questions based on this. I told you in the beginning, this subject is in that sense is a little bit of a nightmare. You have to remember stuff. Only then you can extrapolate things and figure things out. So if you have to remember completely, इसके बाद भी होते हैं यहाँ पे cosmic rays होते हैं. You can write that as well after this. This visible spectrum is written from here to 400 to 700. You will find it different in different places. But the largest range you will find is from 380 to 750. Everything will be in between. You know? So these numbers keep varying. I don't know what is in NCRT. How much is in NCRT? In NCRT is given from 400 to 750. You write 750. Okay, right actually write that one. 750 to 380 because some places you will see that also. Whatever value you will see will be somewhere in between these ones. And remember, or not, not only remember the order, remember which order did you remember? Did you remember increasing frequency or increasing wavelength? Because they'll flip that and ask you different questions, you know. And this the you already know this is what with your this is red having the maximum wavelength and violet having the minimum. We have long radio waves, microwaves. IR is infrared. Sometimes in some cases you will see this division is divided into two things, infrared and long infrared. You can write that as well. Then you have visible region, then you have UV, then you have X-ray, then you have gamma, and then you have cosmos. That's increasing value of frequency. So as you see, these values are not really aligned here in between because these are suggestive values, you know. Little bit here, there, not like precise exact values, they are suggestive values. This thing is like a continuous band. We will talk about that when we talk about Howard spectrum. When you get light EMR, you can have it in form of line and you can have it form of band. So if you have only one particular frequency, that will give you a one particular line. If you have range of frequency, that will give you a band. So that's, you can have a line spectrum or you can have a band spectrum. So this is clearly band spectrum. And the second aspect is that band spectrum or line spectrum can be discrete or it can be continuous. So are there specific frequencies only for which you are getting the radiation, or for all frequencies you are getting the radiation? So as you can see, this is across all frequencies. There is no gap in between. It's a continuous band spectrum. Okay. Okay. So that's it for today. Um, right. The homework is chapter 1 NCRT from page 1 to 50. Shouldn't take more than an hour. Do it, है Thank you. See you tomorrow.
Any doubts in the homework? Template problems. Okay. To me, fx is 3x plus c, f0 is equal to f dash j0 is equal to 1, f2 they are asking you. Differentiate this function, you will be getting 3, you will be getting, right? The differentiation of this function is going to yield constant only. It's not going to give you 1. Okay. There might be some mistake in this question. What else? Took the reciprocal, right? 1 by y is equal to a minus z. After that, z you can separate and then differentiate. What exactly you're getting? Question number third, okay. Y is equal to sine x. Then, so you have to verify the option. Okay. dy by dx, that means minus of cos x. I'll just quickly verify it. Minus of cos x and sin x. That means minus cot x you are getting. And this is coming out as 1 by x they have given. Okay. 1 by x plus cot x. Minus cot x you are getting, no, on the left hand side upon differentiating it. dy by dx divided by y. Minus cos x, sorry, cos x divided by sin x, correct, huh? Cot x you should be getting in this case. 1 by x is remaining in that case. Okay, if we separate this value of x, what do we get here? X is equal to sine inverse of y. So that way, the differentiation of 1 sine inverse of y will be 1 upon under root 1 minus y square. Derivative of 1 sine inverse y did you use? Did you try to verify that? Just check it once. X will be equal to sine inverse of y. And when you differentiate that, you will be getting 1 on the left hand side, and on the right hand side you will have 1 upon under root 1 minus y square. Sine inverse x ka derivative is 1 upon under root 1 minus x square. Okay. dy by dx is what they are asking you. 1 minus x, sorry, 1 minus x square is y square, right? So now when you differentiate this function, you will be getting it as dy by dx is what they are asking. You will have to express it in form of y also. Did you check that? Did you check doing it? Show me. Okay. You're talking about question number 7, no? X is given as under root 1 minus y square. And dy by dx is what you are supposed to calculate. So first I'll do the plain differentiation here. X square will be equal to 1 minus y square. 2x will be equal to minus of 2y into dy upon dx. Okay. Direct differentiation we are doing. So from here you are going to get, this 2 is getting cancelled out. You are getting dy by dx as minus of x upon y. This is one option. None of the option is matching this. Okay, fine. Now apart from this, If we do the direct differentiation, we'll be getting 1 on the left hand side. This will be coming out as 1 upon multiplied by minus of 2y, correct? अरे यार, okay, fine. Okay, so this way you are, and this multiplied by dy upon dx we can write, okay? We have differentiated both sides with respect to x in this case. So what value of dy by dx we are getting from here in terms of y? This 2 is getting cancelled out. So we are getting the value as 1 minus y square upon y with a negative sign, okay? So none of the option is matching this also. Fine. Rationalizing it is not going to yield anything, right? Fine. 1 minus y square. Dy upon dx. Direct derivative is giving you this option. There's no option matching. C. Okay. Root of 1 minus y square, 1 minus 2y square. Fine. Squaring both sides is not going to give you anything. X ko, if I'm replacing it, still I'm going to get the same answer, no? Anyone got the answer for this? I think there is something wrong with this also then. Okay. Question number 12. One or two here or there might be a few mistakes. Okay, in the questions. Which one? Question number 12. Okay. X times under root 1 plus y plus under root 1 plus x is equal to 0. dy by dx is what we are supposed to find out. If we differentiate here, what do I get the value as? There's multiple ways we can differentiate it. Direct apply the product rule here, or we can separate y in terms of x and then differentiate it. So 1 plus y will be equal to minus of under root 1 plus x divided by x. If we square both sides, what do we get here? This is what we are getting now. So y will be equal to x plus 1 minus x square upon x square. So now if I make use of this division rule, dy by dx is coming out as how much? This will be x square into 1 minus 2x minus of x plus 1 minus x square into 2x whole divided by x square. 1x is getting cancelled out. What are you left with here? X power 4, correct. X cube should come here. So upon factorizing, what are you getting? X minus 2x square plus 2x square will get cancelled out. Minus x will get cancelled out. So we are only left with minus 2, right? Minus 2 upon x cube is what we are getting upon factorization. X, this minus 2x square plus 2x square is getting cancelled out, plus x minus x is getting cancelled out. So we are remaining with minus 2, no, in the numerator, plus x minus 2x. Where exactly you are asking? Is there any mistake in the factorization that you are pointing out? So what is the final factorization giving you? Plus x from here. Okay, minus 2x we are getting. Correct, correct, correct. So the value should be 2 minus 2x, right? 2 minus x whole divided by x cube. Correct. Minus 2x plus x. That means minus x we are left with. And minus this minus 2 will be remaining. So minus 2 minus x, correct. Minus 2 minus x divided by x cube. No? Do the factorization and tell me the answer of numerator. What is the value of factorization? Like after factorization, what exactly you're getting? 2x square is getting cancelled out. 1 plus x will get cancelled out here because we have a minus 2x in this case. Then minus 2 is there. So minus 2 is remaining. And then minus x is remaining. Is there anything that else that we are missing out here? Fine, no? Minus of 2 minus of x divided by x cube. So no such options are given or what? Okay, what if we eliminate x in terms of, okay, no, y is not given. Everything, all the answers is in terms of x only. Fine. X plus 2 divided by x cube is what we are getting, no? With a negative sign. Answers are not given in terms of y. Then this should be the answer. कुछ गड़बड़ है और बताओ और कुछ है तो मॉड्यूल questions are done, all the questions from module. Okay, write down applications of differentiation in physics. Few applications we will see anyway. While we go down the chapter, kinematics, laws of motion, will be coming across all these again. Write down some applications in physics. So position velocity, I had told you the relationship, right? What was the slope of tangent of xt graph? Instantaneous velocity at a point at a particular instant of time, right? So let's say x as a function of t is given and you are supposed to calculate velocity as a function of time or velocity of the body at a particular time instant. What will you do in that case? You will be differentiating that function to get the value of velocity. That's what we had seen, no? Velocity was coming out as dx upon dt, okay? Now what if we differentiate this velocity? What was the rate of change in velocity vector? That was acceleration, no? You had seen that in your lower classes also. Rate of change in velocity is called as acceleration. So as I already told you the meaning of this dx by dt, in the same way you have to relate it with differentiation. Acceleration will be given as dv upon dt, okay? Now if I perform a chain rule over here, what do I write? Can I write this as dv by ds multiplied by dv by dx, let's say? dv by dx multiplied by dx by dt, can I write? Using chain rule, let's say velocity is not a function of time, rather a function of position. In that case, you can make use of this chain rule. So what exactly we are getting from here? V multiplied by dv by dx. Okay, so acceleration as a function of velocity, like in terms of velocity, can be given like this. Using derivative, you are able to find out all these, right? Or in turn, can we also say that like from here only we are saying this, since acceleration is dv by dt, if we substitute the value of v in terms of x directly here, so can I write it like this? d dt of dx upon dt, d dt of dx upon dt. So what is d dt of dx upon dt? We call this as double derivative of position, okay? second derivative of position also, you can say this. So symbolically it is represented like this, d square x by dt square. Okay, that means, this means that you are differentiating x twice with respect to time. Okay, differentiated once you will be getting velocity, again differentiated you will be getting acceleration. Or alternatively you can directly write acceleration as d square x by dt square also. So these are about the motion parameters. Fine. What was force? Tell me. According to Newton's second law of motion, how did you define force? Rate of change in momentum. Again, rate of change is coming. What is the meaning of that? Force can be represented as, momentum is represented by m times v, no? M multiplied by v. So can I write this as d dt of momentum will be equal to force, and this momentum is m times v, so we'll be getting this as d of mv multiplied by dt. Again, velocity can be a function of time, or directly momentum can be given as a function of time. We can differentiate it to get the value of force at a given instant of time. Okay, so can we write this as m times, again product rule will be applicable. If I apply product rule in this case, mass can be constant, mass can be variable also, right? If I have a system wherein the mass is remaining constant, in that case directly m can be taken outside as per the rule of differentiation, right? Constant has to be taken outside the derivative. So either you take this m outside directly if mass remaining constant. If mass is not remaining constant, let's say rocket propulsion system is given to you. Rocket propulsion, what happens to the mass of the rocket? It ejects the fuel, no? Because of that, the mass of the rocket keeps on decreasing. Under such circumstances, you cannot take this m directly outside. Rather, you'll have to go for product rule. So if we apply product rule, what do we get here? M dv upon dt plus v times dm upon dt, right? Mass is also changing as a function of time. The rocket is ejecting some fuel out. So because of that, the mass is changing. So if mass is a function of time, in that case, you will be writing it like this. This term, what is dv by dt? Tell me. This is nothing but the acceleration of the rocket, no, or acceleration of the body in this case. So mass multiplied by acceleration plus v times dm upon dt is what we are getting. Okay. Rate at which the mass is being lost by the system is dm by dt. Write it down. This you will come across in kinematics chapter once again, but for the time being, I'm just telling you a few applications so that we can proceed for a few problems based on that. Okay, graphically, what is the meaning of all these? Tell me. V is given by dx by dt. This we had already seen in the last class. What is the meaning of this? If position time graph is given to you, you will be calculating the slope of position time graph at a particular instant of time to get the velocity, instantaneous velocity. Now similarly, what about this one? What does this indicate? The second expression. Acceleration of a body can be given as the slope of velocity time graph at a given instant of time. Okay. Or you can also say the product of velocity multiplied by slope of v versus x graph will give you the value of acceleration. Okay. What about this? Momentum versus time graph is given. You will be taking the slope to get the value of force. Usually in most of the situations, you will be having a constant mass system. In that case, the second term will vanish. So you'll be only left with F is equal to ma to deal with. What else other than that? Let's say in 10th standard, I think you would have studied about current, right? What was current? Again, rate was involved there, right? Rate of flow of charge. Rate of flow of charge was current. So how do we represent current as? Q is charge. We denote charge by Q letter. So dq by dt will be the value of instantaneous current at a given instant of time through the cross section of the wire. Okay. Rate of flow of charge is current. So dq by dt should be the value. What other things, other definitions you have seen wherein rate was involved? Just try to recall that, recollect that. What was the other term that you had already seen in your 9th, 10th standard, wherein you talked about rate. Anything else apart from this? These things so you have seen, no, in your early classes also. Force, current, then velocity, acceleration, all these things you had defined in terms of rate only. So try to solve this question. Acceleration is dv upon dt, the acceleration at t is equal to 1 second. I hope you can understand. What is the answer for this? Tell me. What you will be doing here, velocity as a function of time is given. That means velocity at a given instant of time is given to you. A general function is given. You want to calculate the velocity at any instant of time, put the value of that time here, get the value of velocity. Okay. So velocity at any given instant time is given by this. Acceleration at that instant will be how much? So we know that instantaneous velocity acceleration will be given by dv by dt. The word instantaneous will come into picture if we are talking about the derivative of that function with respect to time. And the word average will come if we are taking a delta function for that. Okay, for a finite interval of time, if you are observing the motion and you are analyzing the acceleration, in that case it becomes average. Okay, so this will be instantaneous acceleration. What is the instantaneous acceleration here? Differentiation of this will be how much? 60. T square derivative is 2t. So 2t into 3 is 60 minus this 1 ka differentiation is going to be 0. So 60 is the acceleration. What kind of a motion is happening in this case? Is it a constant acceleration? Is it a constant acceleration? Is it remaining constant with time? Not remaining constant with time, no. We call this as non-uniform acceleration, right? Whenever acceleration is a function of time, it does not remain constant. Uniform acceleration cases, you might have studied about those equations. V is equal to u plus at, s is equal to ut plus half at square. Those all equations are applicable in case of uniform acceleration. This is a case of non-uniform acceleration, wherein acceleration is coming out as 60. So now acceleration at t is equal to 1 second is what they are asking you. The value of acceleration will be how much? 6 meter per second square. Acceleration at t is equal to 1 second. Okay. What's the answer for this? Momentum of a body moving along a straight line is given as a function of time. Force acting on the body at t is equal to 2 seconds. Again, differentiate it to get the value of force. dp by dt will be 2t plus 2. Correct. So now if you put the value of t as 2 seconds, you will be getting this as 6 Newton. Fine. Direct questions these are. This one, velocity of a particle at t is equal to 2 seconds. You can calculate this. Velocity as a function of x is given. Net force acting on the body is 0 at what time? Velocity as a function of position is given. At what time at what position the body is having 0 net force on it? For the net acceleration of the body to be 0, sorry, for net force of the body to be 0, can I say that the acceleration should be 0? So simply get the value of acceleration, equate it to 0 and find the answer. So when we find out the acceleration, what is the value of that? Tell me. V dv upon dx, right? The other formula that I told you, whenever v is a function of x, which formula you'll go for? The second formula, chain rule wala formula. V dv by dx, what value we are getting? Ln x, the derivative of this function is going to be 1 upon x. Okay, so this has to reduce to 0. So in that case, what should be the value of x? Should it be equal to 1? Ln of x is how much? Log of 1. Basic maths log is started yet. Okay, fine. So for the time being, you just remember this thing. Log of any base will be given as 0 if inside the bracket you have 1, in the argument you have 1. Okay, because you know that this kind of a situation, if it is given, so how do you represent that? Tell me, in terms of exponential form. e power x is equal to a, right? So suppose if a is 1, so e power, how much should be equal to 1? Just think about it. It has to be 1, no? Is it clear? I mean, x should be equal to 0 in that case. If a is 1, in that case, x should be 0. So that's what we are making use of here. So ln of 1 should be equal to 0. So from there we get the value of x as 1. So D is the correct answer in this. Okay. Write down maxima and minima. Did you solve the questions from your module? Did you practice enough for differentiation? Completed? Not fully. Okay. How many questions you have done so far? 10. Try to complete that. Unless you don't get enough hands-on, it will be difficult while we move ahead. Maxima and minima. Okay. So if any function is given to you and you have to find out the local maximum value. Okay. What do you mean by local maxima and global maxima? There are two terms that we are going to define here: local maxima, global maxima. So the maximum value of a function is global maxima point. Okay. Local maxima, what is the meaning of that? Whenever we say local maxima, it doesn't mean that we are talking about the maximum value of that function. Rather, in the locality of that x, that point is going to be the maximum. If you are taking any range, in that you want to find out, let's say a to b. I have taken the interval of x from a to b, and I want to find out the local maxima in that. What is the meaning of that? In that particular range of value of x, that means from x is equal to a to x is equal to b, what's the maximum value of that function? That is what you are interested in calculating. Okay. So those kind of maximum values will be called as local maximas. Okay. Like in general, what happens is, suppose if I'm talking about this particular function, so at the point of maximas and minimas, what happens? Generally in physics, we'll be going with a general procedure only. Global maxima, local maxima, all these things you'll be anyway studying in calculus chapter when it is taught. But still you should have an idea regarding that. So let's say if I have any function whose graph is given to you, okay, graphically it is represented on xy plane like this. Now suppose if I ask you the point of maximas and minimas, looking at the graph, you can quickly say that, yeah, this point is representing maxima and this point is representing what? Minima. Or the point which is on the hill is representing what? Maxima. The point which is on the valley is representing minima. We call it as hill and valley. Okay. So at hill, what is happening? Just before and just after hill, what is happening? Tell me. What is the value of slope at this point? Tell me. You know that the slope of tangent to a graph at a point will give you the slope of the graph at that point. Okay. So if I ask you the slope of graph, this particular graph at this point, what is the value of that? So slope of graph is nothing but equal to 0. No, you are drawing a tangent at this point. You are getting a straight line which is parallel to x-axis, and we know that the slope of such lines will be 0. So it is very clear from the graph that at the point of maximas and at the point of minimas, you are going to have a 0 slope, right? Even at minima also, when you draw a tangent to this graph, you are going to get a 0 slope only, no? M is equal to 0 is what you are getting. Now, in general, you will not be given with a graph. Though looking at the graph, you could directly identify that, yeah, this point is representing maxima and this is representing minima. In general, rather you will be given with a function. Y is equal to, let's say, minus of x square plus 2x minus 1. Okay. This kind of a function is given to you. And I'm asking you to calculate the maximum value of this function, or where exactly the maximal or minima is lying. Okay. So now, since you have already understood that if a given graph is given to you, you can quickly identify that wherever the slope is going 0, that point is going to become maxima or minima, right? So slope, how do you calculate for this graph mathematically? Y versus x graph equation relationship is given to you. What is the slope of y versus x in this case? Tell me. Dy by dx will give you the value of slope. So if you calculate dy by dx in this case, what exactly you're getting? Minus 2x plus 2. So now equating this to 0 will give you the value of x as how much? 1. So you can quickly say that, yeah, at x is equal to 1, this value, this function, whatever this function is going to have 0 slope. What is the meaning of that? Either it can attain maxima or it can attain minima. You cannot comment on whether it is maxima or minima, right? Though you understand that, yeah, it is a downward facing parabola. So because of that, it has to be a maxima, right? You understand that point, no? But let's say if I had given you a function which is unknown to you, you cannot figure that out, right? So you differentiate it once, equate it to 0, you get the value of x. And you are saying that, yeah, at x is equal to 1, my graph, slope of the graph is going to 0. So either it can be maximum or minimum. Now, how to distinguish between these 2 points? So if I talk about maxima, tell me the slope of the neighboring points in this case, slope of the graph at neighboring points. Let's say I take a point which is slightly to the left of this maxima and slightly to the right of this maxima. What's the value of slope at this point? Tell me, slope of tangent to this graph. Is it positive or negative? I'm not asking exact value of this. So in order to find out slope of graph at this point, what do? You draw a tangent at this point. So what kind of an angle it is subtending with respect to positive x-axis? Acute angle. So tan of acute angle is positive. So can I say that at this particular value of x, which is x2 minus h, left hand side, okay, left hand limit that we were talking about yesterday. So like on the left hand side of this point, we are going to have a positive slope. Theta is acute, okay. What about the value of slope on the right hand side of this? Tell me. Obtuse angle you are getting. So it is turning negative. So when you are moving from left to right across a maxima, how did the slope change in this case? Slope is also changing, no? Slope is changing as the x is increasing. So can I not say that slope is also a function of x? So as x is increasing, the slope is going from positive to negative. So can I say change in slope in this case is going to be negative? Final slope minus initial slope divided by delta x. Final slope minus initial slope divided by delta x. What will be the value of that? That will be negative, no? So can I say that if the point x is equal to 1 is a maxima, in that case, the rate of change in slope with respect to x should be negative. Is that clear? To the left of it, the slope was positive. To the right of it, the slope is negative. When we take the change in slope with respect to change in x, in that case, what exactly we are getting? We are getting negative value. So using that, we are quickly able to say that rate of change in slope with respect to x, what is the meaning of that? D dx of dy by dx, isn't it? Y versus x, what is slope? Dy by dx. So rate of change of slope with respect to x is what we are taking. So d dx of dy by dx should be lesser than 0 if it is minima. Sorry, maxima. We have taken maxima point, no? In a similar way, what can you observe here? Tell me. What do you observe in this case? You are moving from left to right across a minima. So what exactly you are able to observe here in terms of slope? So earlier the slope was negative and then the slope turned into positive. So change in slope is how much? Positive value minus of negative value. How much will that be? Positive, no? So change in slope is positive with respect to increasing x. So now in this case, can I say rate of change in slope with respect to x will be positive if we are crossing a minima, okay? So if d dx of dy by dx turns greater than 0, we get a minima, okay? So basically, in order to identify whether the point is given point is a maxima or minima, what are you supposed to look into? You are simply supposed to go for second derivative test. First derivative test simply tells you about whether the point is going to be a maxima. I mean, it is only going to give you those points where the slope is going 0. It can be maxima, it can be minima. But to further uncover it, whether it is maxima or minima, you'll have to go for double derivative test. That means you have to differentiate this function once again, check whether it is coming out to be negative or positive. Based on that, you will comment on the maxima or minima points, okay? So if you differentiate this function once again, how much you are going to get? Tell me. Treat this dy by dx as any general function and differentiate it again with respect to x. How much you are going to get? Tell me. And that we call it as double derivative, okay? D square x by dx square. How much will be the value here? minus 2, and 2 is a constant, derivative is going to be 0. We are going to get this as minus 2. Now we don't have to even substitute the value of x is equal to 1 in this case. Directly we are getting d square y by dx square as negative. What is the meaning of this? In fact, minima is not even existing. Directly we are getting that there is a maxima in this case, and the maxima is lying where? Since it is less than 0, that's the reason why this point x is equal to 1 is representing maxima. So if I ask you what is the maximum value of this function, what will you do? Y max will be equal to how much? You got to know no, that yeah, x is equal to 1 is that point where the function is attaining a maxima. So y max will be equal to, simply in place of x everywhere you will have to put the value of x as 1. So how much you are getting? Minus 1 plus 2 minus 1, which is coming out to be 0. Okay, so y max is 0. Now the other values of y will be coming in terms of negative, and that you can visualize also. Just imagine about the graphical representation of this equation. It is going to be a downward facing parabola with vertex on the x-axis, isn't it? With vertex on x-axis. Where exactly the vertex will be lying? 1, 1 comma 0, right? So vertex is on x-axis. So definitely, like the other values of the function y is equal to fx is going to be negative. So write down all these points one by one. In short, the steps are simply you have to differentiate the function, equate it to 0 in the first step to get the points where maxima and minima could lie. Okay, and in the second step you will again differentiate that function at those values of x's. You are going to check whether the given d square y by dx square is less than 0, greater than 0. That you will use to identify the maxima and minima points. Write down a question based on this. The perimeter of a triangle, the perimeter of a triangle is given as 100 meter. The perimeter of a rectangle is given as 100 meter. The perimeter of a rectangle is given as 100 meter. Determine the length and breadth of the rectangle. Determine the length and breadth of the rectangle for which its area is maximum. For which its area is maximum. Got it. 625. Side length 25, 25. I mean, square is also a form of rectangle only, no? Anyway, you have to, your problem statement is to maximize the area and not judge whether it is going to be a square or rectangle. What is given here? Value of perimeter is given as 100 meter. This thing is already given to you. So L plus B will be equal to how much? 50 meter. Now what's the value of area? Length into breadth. So this area function you have to maximize in this case. Now you have two variables in this case. L can be changed, B can be changed. Actually, you can have infinite number of possibilities here, right? You can have a rectangle whose breadth is 1 meter and length is 49 meter. You can have a rectangle whose breadth is 2 meter, length is 48 meter. There are infinite number of possibilities of constructing a rectangle out of this information. So now you have to choose that one particular value of length and breadth for which area gets maximized. So we know the concept of maxima and minima. We'll make use of that to find out to maximize this area. But for that you have already seen that whenever y is a function of x, so basically it was dependent on single variable, right? So you have to bring it into a single variable function first, because L is a variable, B is a variable in this case. How will you eliminate L and B? Make use of this equation that is there with you. So either you write L in terms of B or you write B in terms of L and then try to maximize it. So what's the value of B in this case? Tell me. Can I write it as 50 minus L? Now if I substitute that in this equation, what do I get? L times 50 minus L. So that way we are going to get a function like the previous one, no? जैसा last वाला function था वैसा आ जाएगा अपना, y is as a function of x. Now then you can use the same procedure to proceed for the maximum area. Okay, so A is given as 50L minus L square. Now if I differentiate this, since we have brought it into a single variable form, so if I differentiate this with respect to L, we'll be getting this as 50 minus 2L, which means the value of L is going to be 25. And if L is 25, B has to be 25. Now double derivative directly going to give you minus 2, no? It's clearly visible here. If I differentiate it once again, I'll be going to get the value of dA by dL as how much? Minus 2. Okay. And whenever you have second derivative as negative, we are going to get a maximum value at that point. So value of L is coming out as 25. We can say that A max will be how much? L into B, which is 25 into 25. 625 meters square. Okay. This can be the maximum possible area in this case. Write down another example. So there's a person who is standing over here. Okay. This side we have field and this is highway. Let me mark this point as Q. So velocity of the person in field is given as meter times velocity of the person in highway. Okay, where this neta is less than 1. Okay, write down determine first one, the distance covered by the person, determine the distance covered by the person to go from, distance covered by the person to go from P to Q, distance covered by the person to go from P to Q, if he wants to, reach point Q in minimum possible time. If he wants to reach point Q in minimum possible time. These distances are given to you, D and 2D. Minimum possible time. Second one is also a kind of part of first one only, write down. At what distance from point Q, at what distance from point Q, at what distance from point Q along the highway he should land. Along the highway he should land from the field. Along the highway he should land from the field so that the above condition is satisfied. So that the above condition is satisfied. So his velocity in field is lesser as compared to the velocity of man in highway. Okay. What's happening? His velocity in field is lesser than velocity on highway. So he could have chosen this path, right? He could go like walk d distance in the field, then walk this total distance 2d. But in that case, he'll be ending up walking more distance. So probably there will be more time required in order to reach that point. Okay. The other possible way, he could have gone via this way, right? Directly from P to Q. If he directly goes from P to Q, in that case, what will happen? Though the distance will be minimized, but at the same time, velocity is also less, no? So probably the time taken can be even more. Okay, so we are not sure about it. Even the value of neta is not identified. I mean, it's not given to you. Simply it is given that it is lesser than 1. Okay, so you cannot actually comment in that way that he will walk like this and then after that he'll go this way. Neither he can go this way. So you'll choose a general path in going from P to Q and then try to minimize it, minimize for the time, get the answer from there. I mean, you have to minimize the time, right? That is what you're required to do. So somehow, suppose if you are choosing a general path, let's say he started from this particular point, landed on the highway somewhere here. Okay. And then after that, he is walking on the highway this particular distance in order to reach in minimum possible time. This is a general path that I have taken. This distance can be 2D, this distance can be 0. We are not sure about it. Okay. So that's the reason why I've chosen a general point where he'll be landing and after that he'll be walking this entire length of path. Okay. So can you find out the time taken in going from this point to this point and then again time taken from this point to this point? Somehow if you are able to relate it with some function, then in that case you can minimize that time using maxima minima and then get the answer. Try to figure out the answer for this. Suppose wherever he is landing, he is at a distance of x from Q. Okay. So you calculate the path length of this. What will be this remaining distance in that case? 2d minus x, no? So 2d minus x and this is d. So can you find out hypotenuse in this case? So this length, that way you will be able to calculate, and inside the field the velocity is known to you, which is equal to Vf. Okay. And while he is going from here to here, he travels a distance of x, his velocity is Vh. And the ratio of those two is known to you, neta. So try to make use of that and figure out the answer. Write down function of time, then after that try to minimize it. What is this distance? Tell me. If this is x, this I have assumed as x. Can I say this will be 2d minus x? That way, this distance is d1, suppose, and this is d2. D2 is anyway x. So can I say time taken to go from here to here? Let me call this point as r. So time taken for PR is going to be how much? His speed is remaining constant in the field and even on the highway, right? Distance by speed is giving you what? Value of time, no? From here to here, this is the distance, path length covered by him. That d1 divided by vf will give you the value of time, t1. So this distance d1 is how much? Under root d square plus 2d minus x ka whole square. Whole divided by vf we can write. Okay, this is tpr. Time taken to go from r to q, how much is that? Distance covered is x, and time taken is, sorry, velocity of the person is vh. Okay, so these are the values of different time instants on the highway and in the field. So now can I say total time taken in this case is t net, which is equal to under root d square plus 2d minus x whole square whole divided by vf plus x by vh. Now what do we need to do here? X is something which you can control, no? He could have landed here, he could have landed here, he could have landed here, he could have landed at this point. Okay, so x is something which is variable. So whenever you have the function in terms of one single variable, what do you do there in order to minimize or maximize? Differentiate that function with respect to x, equate it to 0, try to figure out the value. Nx power n minus 1. Okay, so can I write this as half x power minus half, which is going to be 1 by 2 root x. So whenever root x is differentiated with respect to x, you will be coming up with this answer. What if I ask you root of sine x you have to differentiate with respect to sine of x? What should be your answer in this case? In fact, root of any star with respect to that star will be given as 1 by 2 root star, no? Can I say that? Root x with respect to x derivative is 1 by 2 root x. So d of root of any star, this star can be anything, sin x, tan x, log x, with respect to that star, that means with respect to log x, sin x, whatever, you are going to get that as 1 by 2 root that star, no? Same thing I'm asking you. D root of sin x with respect to sin x, how much will be the differentiation of this? You'll be getting this as 1 by 2 root sin x. Okay. Okay. Had I asked you this differentiation with respect to x, what will you do now? Tell me. If I had asked you this kind of a differentiation, d of root sin of x with respect to x, what will you do? So you understand that directly it cannot be differentiated with respect to x. First you will differentiate with respect to sin x, then sin x has to be differentiated with respect to x, right? So chain rule, simple chain rule. Sin x with respect to x is cos x. So cos x will come up, isn't it? So same thing you have to make use of here. You can see that it is not a direct function that we have given you inside the root. So first you have to differentiate with respect to whatever is there inside the root, and then that function needs to be differentiated with respect to x while differentiating this one. Okay, d square plus inside the bracket we have 2d minus x whole square. So this function, this root of this function needs to be differentiated with respect to d square plus 2d minus x whole square. So what will be the value of that? Tell me. 1 by 2 root of d square plus 2d minus x whole square. Okay, is that clear? Differentiation of this with respect to this internal function will be this much multiplied by, what should you do now? You have to differentiate with respect to x, no, not with respect to this particular function. So now this particular function which is inside the root needs to be differentiated with respect to x. So d square derivative, d is a constant, 0. What about differentiation of this one? 2 times 2d minus x. Okay, again, this cannot be directly differentiated. Okay, if I ask you d of sine of x whole square with respect to sine x, what will be your answer here? Tell me. What was the derivative of x square? 2x. So here you will be calling this as 2 sine of x. But if I want you to differentiate this sine of x whole square with respect to x, how will you differentiate this? You will be differentiating first this function with respect to sine x and then sine x with respect to x. Okay, same thing we are doing here. So differentiating this function will require to be, we will require to differentiate this particular thing with respect to 2d minus x first and then 2d minus x with respect to x. So what value we are going to get here? Twice of 2d minus x, and minus x derivative is going to be minus 1. Okay, so now if you equate it to 0, how much are you getting? This function, if you equate it to 0, how much are you getting here? What's the value of x that you are getting? Is this differentiation clear? What are you getting after equating it to 0? X ka value 2d minus nd 1 minus n square. This is what you are getting. Which one? Okay, okay, understood. So you are trying to say this, no? 2d minus of this thing. It is outside and this remaining thing is in the fraction. So x ka value you got, the answer for the second question you got. Now distance traveled you have to find out. So wherever x is given to you, you in place of that you have to substitute this. Because when you go for differentiating it once again with respect to x, this function, you are going to get a negative quantity only. Sorry, positive quantity only. Okay. In general, if they directly ask you to minimize the time in physics, most of the time you will be your effort will be saved directly by single derivative. You will be able to find out the answer in most of the cases. Okay. So if I ask you to minimize the time, in one differentiation, whatever you got, you can go ahead with that actually. Okay, in most of the cases you can see that in physics. Okay, this thing, when you equate it to 0, you are going to get this x. Now substitute the value of this x in this particular equation, this equation, to minimize the time. Okay, that minimum time was asked or distance was asked. So for minimum time you can do that. For distance anyway, like this plus this will be the distance, no? So in place of x you have to substitute these values to get the value final result. The other way of doing this question would have been to use Snell's law. If we use Snell's law, we know that light always takes least possible time to go from one point to another point. So from P to from point Q, if it has to go, what path it would have chosen? Using Snell's law, we can do that, no? Let's say this person is just like a ray of light. So in which path it would have traveled in order to minimize the time? That will be same as the path that would have been taken by the light. Okay, so now you can understand that the speed of this person inside the field is going to be lesser. So isn't this a denser medium as compared to this? Optics, you have studied this, no? Denser medium, rarer medium. So the person is choosing this particular path because finally the angle of refraction is already known to you, right? He has to walk along the highway, no? Along the highway means what? If this is normal, then 90° will be my angle of refraction. If 90° is the angle of refraction, what is the angle of incidence here? Theta c, critical angle, TIR. Total internal reflection you have covered in 10th. At what angle he should be going at this point so that angle of refraction becomes 90°? What do we make use of here? That is TIR, no? So if we make use of TIR here, what do we use here? Mu sine of theta is equal to sine 90, we can write, no? Snell's law, at least everyone knows, right? Angle of refraction is how much? 90°. So can I write, if this angle is theta, mu sine of theta is equal to 1. Because mu is, let's say, in this particular medium, I'm considering the refractive index as 1. Okay, refractive index as in we will try to convert that into the form of velocity. We know that refractive index is inversely related on the velocity of light, isn't it? If the velocity of light in a medium is more, the refractive index tends to be less, inversely dependent upon that parameter. So mu sine of theta is equal to 1, we can write. Now this mu is what? Refractive index of this medium with respect to this medium. Okay. Now refractive index of this medium with respect to this medium will be how much? Velocity of man in this medium divided by velocity of man in this medium, reciprocal of that. So can I write this as velocity on highway divided by velocity in field into sine of theta is equal to 1. From there we get the value of sine theta as Vf by Vh. What is Vf by Vh in this case? Neta. So we are getting sine theta as this value. Now if sine theta is known to you, what exactly you were supposed to calculate? X, no, in the second part of the question. Once x is calculated, other things can be calculated. So for calculating this x, what do you do now? This theta is known to you. Can I say that this angle is also theta? Using this triangle, I will say that sine theta is going to be, sorry, tan theta is going to be this 2d by x divided by d. And sine theta is known to you. What is tan theta? Tell me. What is sine theta in this triangle? Perpendicular and hypotenuse is 1, isn't it? So this base will become 1 minus neta square. Tan theta that way will be neta divided by under root 1 minus neta square. So this you can equate with this side divided by this side, get the value of x from there, and then after that substitute in the equation to find the answer. So there are two ways of doing this, either Snell's law or you can go for maximum minima. Copy this. This is the second method. Write one question. After that, you can copy this. Write one. Write one. In a cylindrical container, in a cylindrical container, water is being filled. Water is being filled. Water is being filled using a tap. Using a tap at a constant rate of at a constant rate of alpha meter cube per second. Alpha meter cube per second. Alpha meter cube per second. If there is a hole at the bottom of the container, if there is a hole at the bottom of the container, whose area is capital A, whose area is capital A, determine the maximum height up to which determine the maximum height up to which liquid can be filled inside the container. Liquid can be filled inside the container. Given that the velocity of liquid given that the velocity of liquid ejecting out through the hole given that the velocity of liquid ejecting out through the hole is root 2gh is root 2gh is root 2gh, where h is the height of the liquid in the container at that instant, where h is the height of the liquid in the container at that instant. This hole is made at the bottom of the container, that I told you, no? Okay. You understand this situation? What is given to you here? There's a bucket in which a hole is made at the bottom. You are filling the bucket from the top with the help of a tap. So, though the tap is filling water, but at the same time, liquid is also coming out of the bucket through that hole. So, what is the maximum height up to which you can fill inside the container? Radius of cross section is something which is constant, right? Of the container. You can consider it to be cylindrical container. What is changing here while the liquid is being filled? Height is changing, right? So can I say that the volume of the liquid filled inside the container is proportional to height, directly proportional to height? In general, what do we write the volume of container as? If it is a cylindrical container, pi r square h. So r is so constant anyway, so it is a direct function of h, volume. Think in that manner, try to figure out the answer. There's a small hole at the bottom here, okay? Let's say at a given instant of time, the height up to which the liquid is filled inside the container is h. What is the velocity with which the liquid is coming out? Root 2 gh, that is given to you already, okay? And with what rate you are filling the liquid in this? Liquid is being filled with the help of a tap, no? Like this. The liquid is pouring inside it at alpha meter cube per second. This situation is given to you. So somehow if we can write down the volume inside the container as a function of time, then our work is done, right? Because we have to anyway maximize the volume. Maximum the volume, maximum will be the height, isn't it? So think in that manner and try to figure out the answer. The volume inflow in this case is alpha. What is the outflow of volume? The difference of those two should be giving you the value of volume flow rate, isn't it? Can I say dV by dt? Volume flow rate is dV by dt. Volume flow rate, what is that? dV by dt. So dV by dt will be equal to how much? Inflow of the volume, which is alpha, minus outflow of the volume, which we are supposed to figure out here. The area of cross section of the hole is how much? A is the area of cross section of the hole that is given to you. So what is the rate at which the liquid is ejecting out? At any given instant of time when the height is h. With what rate it is ejecting out here? Tell me. Area of cross section is given. Through that area of cross section the liquid is coming out. And velocity is given. Let's say in 1 second if I ask you what is the volume coming out, that is only the volume flow rate, no? Outflow of the volume. How much will that be? A into root 2 gh, correct only. See, density is rho. If I ask you mass flow rate, density is rho, suppose. So mass flow rate is density multiplied by the volume which is coming out. Though we require only volume flow rate in this case. So what is the volume which is coming out in this case? So every second, can I say through this cross section, a cylindrical shape of liquid is coming out whose length is going to be v, where v is the velocity of efflux. Can I say that? Is it clear to you? Let's say in 1 second, if I ask you what is the volume coming out, so area of cross section, just imagine that situation. The liquid which is coming out will have some cross section, and that cross section will be equal to how much? The cross section of the hole. And what length of the liquid will be coming out in 1 second? V multiplied by 1, velocity into time, isn't it? So velocity is root 2 gh. So directly we can say, no, area multiplied by the velocity with which the liquid is coming out, that will be equal to the velocity of outflux, sorry, the volume of outflux. So what will be the value of volume flow rate outside the container? That will be equal to A times under root 2 gh. Is this clear? Tell me first. Outflow of the volume, area of cross section of the jet which is coming out, that is A, and what length of the jet is coming out in 1 second, that is root 2 gh. So that's the reason why we are saying that every second A times root 2 gh volume of liquid is coming out, given that the height at that instant is h. So now volume flow rate you have already mentioned here. So actually you are one step ahead here. You didn't write volume as a function of time. Rather you directly wrote dV by dt, the volume which is remaining inside the container. Because we are supposed to maximize this volume, no? So somehow dV by dt we have already figured out. So all we need to do is equate this to 0. If we equate this to 0, what we will get here? What was the steps that were involved? Well, volume as a function of time you would have written, again differentiated that function, equated it to 0 to maximize the volume. So here we are already one step ahead. We didn't go for calculation of volume, rather we wrote volume flow rate out, inside this container. So inflow minus outflow is the total volume which is remaining. Okay. So this volume flow rate, you can equate it to 0, then get the value of h from here. That will be the maximum possible height. So what value you are getting? Alpha by A is equal to root 2 gh. Squaring both sides, you are going to get this as 2 gh is equal to alpha square upon A square. That means h will be equal to, this is the maximum height that can be remaining inside the container. Write it down. Maximum minima problems are there in that DPP which I had given you yesterday. It is there. Okay. Show me the DPP once. नहीं 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 नहीं, DPP का बात कर रहा हूँ, जो मैंने कल दिया था वो पैम्पलेट जो तुम बोल रहे थे अभी, पैम्पलेट में नहीं था. ओके. शो मी द DPP वंस, नो, जो मैंने दिया था कल, वही पैम्पलेट वाला. ओके, बेसिक डिफरेंशिएशन ही है बस. दिखाओ जरा. 65 से 74 तक कर लेना, मैक्सिमम मिनिमा के क्वेश्चन है. 65 to 74, इनफैक्ट 64 तक बोल दिया था क्या मैंने? ओके. 65 to 74 you are supposed to solve. ओके. नेक्स्ट क्लास में देखेंगे हम लोग थोड़ा सा मोनोटोनासिटी, एंड आफ्टर दैट विल
Yeah, I've tried those questions. Yesterday, what we are given. Those last three questions. Got it? So we'll discuss some problems, and we'll also look today in today's lecture about Diophantine equations. Mm. First, we'll see that last yesterday's class questions. Okay, so the last three questions and that factorization based question, what I have left in the ending. Is that also done? This a plus b plus c question. A plus b plus c is equal to 0. We have done up to a certain extent, and I've asked you to try. No, is it finished? Amber got it. So what was the question we had? A plus b plus c is 0. Then prove that. I think it was a square by. What is the question? 2a square plus bc. So sigma of this is equal to 0, right? Acha, answer will be getting it as 1. It is proof question or it's not a proof question? Yeah, I got it. It's simple. Find the value of this. Sigma of this is what? Okay, so whatever you have done, proceed in the same way. So I think yesterday what we have done. So we have written this as a square divided by 2a square plus bc, you get as a square. And 1 a square, 1 a written as minus b minus c plus bc. And when you're factorizing this, I think you have got as something in the form sigma a square divided by. So if you look in the denominator part, so you're getting a square minus ab minus ac plus bc, right? And if I factorize it, I'll get a into a minus b minus c into a minus b. So it is going to be a minus b into a minus c. So this is what you got, a minus b. Right. So after this, I've asked you to try it by taking LCM. That's how you're done. Okay. So if I see the expression here, you're having a square divided by a minus b into a minus c. If I expand that sigma, then I'll be getting it as next time as what? B square divided by. I'll be getting it as b minus c into b minus a plus c square divided by c minus a into c minus b. Right. This is how it looks like. Right. And if I take the LCM, so LCM is something like to you, I'll take the LCM as a minus b into b minus c into c minus a. Right. Anjani? Anjana, right? Yeah, you have done this after this. No, no, no. You're there. No. Fine. So after this, what we'll do here now? So I'll take what is the LCM here? I'll be getting. I'll multiply c minus b, right? Because a minus c is there. So negative of. I'll multiply and divide with b minus c. So negative of b minus c will be c minus b. Next time, what you're going to have, sir? It is something like b square. You're already having b minus c and b minus a. So since you're having b minus a, so I'll multiply with what, sir? I'll multiply with a minus c. And same thing I'll do here now. I'll take c square. So I should have c minus a is there. C minus b I want. So there is c minus b. That means I'll be multiplying with what? B minus a. Okay. It fine. So b square. So b minus c is there. B minus a. So negative of c minus a is this. C minus a into c minus b. You already had here c minus a. So c minus b. So negative of a minus b. So this is what you're getting in numerator. Now numerator, what you're trying to do after this? Factor it. You can see here. Is this looking like to like again a cyclic expression? If I observe this, it is an expression in terms of a, b, c, right? If I assume this numerator part, so this is an expression, or I can say this entire thing is something like to you a function in terms of x, y, z. This expression E is a function in terms of x, y, z, right? oh, sorry, A, B, C. The variables involved here are A, B, and C. If I am replacing A with B, if I replace A with B, what is going to happen? If I replace A with B, this term is 0. And what is this term you will be getting? B square into C minus B. If I'm just replacing A with B, so replacing A with B will make it what, sir? What am I going to get if I'm trying to replace A with B? So this is going to be B square into C minus B plus B square into B minus C. What is this value going to be? I'll have it as B square C minus B cube plus B cube minus B square C, right? So what is this entire value going to be? That means what I can say here now? Can I say anything? You can say A minus B is a factor, right? So I'm just trying to bring factor theorem. See, one thing is you can try to factor it. You have factorized it. Huh? After this you have factorized it, you apply the factor theorem. So I'm just trying to apply the factor theorem. What does factor theorem state, sir? In polynomials. For example, if P of X is a polynomial, right? And if P of A is 0, that means what is the meaning? So for example, if I have a polynomial, so for polynomial P of X, if P of A is 0, that means what I can consider for this polynomial? A is a root, I can say, for the polynomial equation. Or I can say X minus A is factor of P of X, can I say? This is what is going to be factor of P of X. So same logic, when you're trying to factorize a algebraic expression, this algebraic expression has almost a function in terms of 3 variables. Now if I am replacing A with B, this expression is becoming 0. That means what is the meaning, I can say? Is A minus B a factor? Right? Same thing will it happen if I replace B with C? So B minus A factor. Same thing will happen if I replace C with A. So C minus A is a factor, right? So I can say here now, using factor theorem, I can definitely say this particular expression, whatever you're having it. So I can say now here A square into B minus C plus B square into C minus A plus C square into A minus B. This expression, whatever you're having it. So this is what you are having, right? B square into A minus C, C square into B minus A. First is also C minus B, right? A minus B, B minus C. So this particular expression, whatever you're having now. So for this particular expression, what are the factors I'm getting? I'm getting A minus B a factor. I'm getting B minus C a factor. I'm getting C minus A factor. That means, can I say this is going to be A minus B into B minus C into C minus A? Can I say? Can I say this? Right? Apart from this, will I get any other factor? How do you decide it? Because just look at the degree part. What is the degree here in the LHS? Degree is 3. If I multiply this, because if I see A square into C, net degree 2 and 1. 3 is the net degree, right? So here also, if I'm trying to multiply these 3, what is the net degree you're getting? You're getting 3. So factors degree is matching. So I cannot get any other extra factor, right? But are you sure the constant has to be 1 here? We don't know. So I'll just write it as k times of this, right? Because if I say for a polynomial, okay, there is a polynomial for which x minus a is a factor. So in that polynomial, I can have k into x minus a also, right? A constant into x minus a also can come, right? So that is the same logic. K into this. Did you understand why you're writing k? Right now, how do I find this value of k? What do you can do to find the value of k? It's just no, it's like a formula only, right? It's a factorization. It's like identity. So since it's an identity, I can give any values of a, b, and c, right? So one thing is you can expand it. You can compare the coefficients part and figure it out. Or since it's an identity, you can substitute any values. For example, I can take a set of value like maybe a I am taking it as 0. I am taking b as 1. I will take c as minus 1. If I take this as a scenario, then I will get 0 into c minus b, which is minus 2. It's anyhow 0 only. So 0 into minus 2 plus b square 1 into a minus c, which is again what, sir? 1 plus c square 1 into b minus c, which is again what? 1 is equal to you're having k times of a minus b, which is minus 1, b minus c is 2, c minus c is again what? Minus 1. So So this gives you the value here now. I am getting 2 is equal to 2k. So I am getting the value of indirectly k value as what here, sir? 1. Right? So if you're getting the value of k as 1, that means I'll be having here now a minus b minus c minus a by this. 1 is the answer, right? You got the same thing? Right? Or were you able to factorize normally? That also you can do it. Okay, so you can just try to multiply the terms and try to take the factors also normally. Or you can also take the help of factor theorem. Is it fine? Right? So therefore, if you look into the answer now, so I can write it as, I can write this entire thing as 1 into a minus b minus c minus a. And here if I am replacing it, you'll get the value as 1. A square minus ab minus ac plus b. Got it? Okay. Right. What are the questions? What are the answers you got for the 3 questions? The first question, I think we have given this thing, right? Product of 3 primes p1, p2, p3 is 5 times the sum of their primes. You got the first question, right? Answer 25, 275, 257. Anything is fine. All of you got it? Anjana, which you got? Okay. You have not tried it, huh? Okay, okay. And yeah, answer is 257. So you can take it in any order. It's fine. And next question, I think I asked you to say this question. 175a plus 11ab plus bc is equal to abc. And do you have anything about abc? Abc are prime numbers. ABC belongs to prime numbers. How many I got? Total 3 answers. Huh? Euro. Any others? 3? Okay. We'll discuss this question. This a okay. We'll check it once. Oh, let me see once. Any other answers you got? Others? What are the answers you got? 2 to 197. Yeah. 37, 7, 37. Okay. Then, yeah. You get three set of answers for this. Then next question. What is the next question I given to you? Find that value. Correct. What is that answer you got? Two answers you're getting. Yeah, I think I've asked you to find a value, no? What I've asked you? Actually, you have found A, B, C, all three values. Okay. What is the answer you're getting? You have to recheck that. Retry it once. 1, 134. I think it's 124. Huh, 134. The highest number will be 134. If you have got this, so you try. Those who have got this, you try one more question. We'll discuss this right now. So those who have got this, you try the next question. I'll give you one equation. Try that. Okay. Solve x square minus 2y square is equal to 1, where x comma y belongs to some natural numbers. Okay. First of all, you figure out how many solutions will be there, and then you try to write the general format of the solution. How do you write the solutions in general form? So if I see this question, so what you will do here? So it seems like one equation, three variables, right? You want the question? X square minus 2y square is 1. X square minus 2y square is 1. So what I'll try to do in this question is, any idea you're getting? So just try to, because there are total three variables, A, B, C are there, you're trying to find the three unknowns. All of them are prime numbers, right? So try to separate either any one of the terms. I'll try to separate A terms or B terms, okay? Because I can see A and B are what are there in each and every term. I'll try to separate those terms. For example, if I separate A terms, no, I'll write BC is equal to, I'll take all the other terms to the RHS. Then what I'll have, sir? I'll have A times of BC minus 11B minus 175. You fine? Now you see here, LHS is looking like what? It is product of two prime numbers. So RHS is also looking like product of a prime number, and this, can you say anything about it? This we don't know. It can be a prime or it can be a composite, that we cannot say it. So you are trying to express product of two numbers in this way, right? So what I can say here now about BC. So BC is product of two prime numbers. At the end, what I am doing is I am trying to express it as product of two factors, right? So how do I get two factors from BC number? So two prime numbers. See how I'm just trying to do the factorization, and I'm trying to write as product of two numbers. So how can I do that? Either I can write as 1 into BC, or I can write it as again what? B into C. I can write as C into B, or I can also write as what? BC into 1. Right. Apart from this, can you write as any other product of two numbers? Any other way of writing it as product of two numbers? I cannot write. Now this has to be equal to this. This has to become equal to this. Means what you can do. For example, if I look into the first scenario, no, either you can say, sir, A can become equal to 1 and the other things can be equal. But will I get any solution in that case? If A, yeah, it's not a prime number, that's why you can reject it. Okay. So here A is equal to 1, you'll get it. So not required. So I can reject this case. I don't want, I want only one prime numbers part. Same thing, I can also reject this case. Now I am getting two scenarios. So if I take, for example, this scenario, I can write B into C. B into C has to be equal to this. That means what can happen, sir? One case I can have B is equal to A. That means I'm getting a scenario like I can have B is equal to A. Okay, so when I look into this scenario, so B can be equal to A, and at the same time, what I can say, C can be equal to what? BC minus 11B minus 170. Is it fine? Yeah, another scenario will have, I can have, what is the other case I can say? I'll have A is equal to C and B is equal to this part. Now I'll try to solve this part. How do I solve this part? I know here A and B are equal. I have one more equation here now. So again here, what we can do? Can't take anything common. I can take B into, I can write as what, sir? C is equal to B into C minus 11 minus 175. So I'll try to bring C minus 11 term over here so that I can again take C minus 11 common and I can factor this expression, right? So to take C minus 11, I'll subtract 11 on both sides. I can add as now C minus 11 is equal to B times of C minus 11. And again I'll have, sorry, 186. Now if I take this C minus 11 to the other side, then I'll get 186 is equal to, I'll have B plus 1, sorry, yeah, I'll have B minus 1 times C minus 11, right? Now this is like product of two numbers, B and C are prime numbers. So product of two numbers. So I'll see how can I split 186 as product of two numbers. So just try to see how do you split 186 as product of two numbers. How much? Yeah, I can maybe I think I can easily see 6 is a factor. So 6 into 31. Or if I still do it, it is 2 into 3 into 31, right? So the factors of this are I can see 2 or 186 is something like 2 into 3 into 31. Now I'll try to express it as product of two numbers. The first thing what I'll do is I'll express it as 1 into 186. Okay, so next what I'll do? I'll try to reduce it. I'll write as 1, 2 into 93. I can write. I can also write as 3 into 62. Right? You can write as 6 into 31. What other ways? Exactly the opposite. Ulta. Is it fine? So I can express it as product of two factors in total 8 ways, isn't it? So I can write it again 31 into 6. Let me write over here. Okay. Hmm? Yeah, correct. Now I'll see here 31 into 6. Or I'll just write the opposite of here. So this is 186 into 1. Then again you're having 93 into 2, 62 into 3, 31 into 6. So I'm trying to find B and C, right? So to find B, what I'll do, I'll simply add 1 to the first part. If I'm adding 1 to the first part, I'm writing BC over here, see it. So B comma C is what I'm writing over here now. Here also I'm trying to write B comma C. I'll simply add 1 to the first part, and I know B is a prime number. So here if I look into it, I'm getting B value as 2, here I'm getting 3, here I'm getting 4, here I'm getting 7, here I'll get 187, here I'll get 94, 63, 32. So since I know B is a prime number, outrightly I can reject some numbers, right? So I can reject this part, this is not possible. I can reject this part, here you're getting 34, what about 186, 187? It's a prime number 187. Hmm? So look into 187, prime or not? Hmm? Yeah. So now I'll look for C case. 187. 11 once 11. Yeah, divisible by 11. So you can neglect it again. Now I look into C scenario. Now C is actually you're trying to add 11 to 186. Since I'm trying to add 11 to 186, so 186 plus 11, that will give me what, sir? 197. And again 93 plus 11, which is 104. Now again, since I want C also has to be a prime number, so I can't take this. So 197 is a prime number. 197. Prime or composite. If I want to check whether it's a prime or composite, what is the nearest square root to 197? Okay, how much? 14 square. Yeah, 196. Just see less than 14. Is there any prime number which is dividing it? 2 will not divide. 3, 5, 7. 7 to 14. 5 is left over. 57 is not going to happen. Then again 11, 13. No, So that means this is one possible solution. Can I say this? So I am getting A as 2. Sorry, I'm getting B as 2 and C as 197. So that means what I can say here in this case solution. So B is equal to 2, C is equal to 197, and I know B is equal to A, right? So therefore I can say solution in this case is A comma B comma C value. If I look into it, both are equal. So 22197 I'm getting it. Did you understand this case? What have you done? Right. Look into it once and try the next scenario now. The next scenario is what here, sir? So the next scenario I can say is here now A has to be equal to C and this has to be equal to B. So in a similar pattern, try to find the other solutions. Okay, write it down and try. It's easy to factorize, right? So now think about the factors of 175. I have to split into 175 factors, and one number has to be b, other has to be c minus 12. So 175 is 25 sevens. So I can write it as 5 square into 7 is this number, right? Now how do I split this again? So I will first write it as 175 into 1, okay, or I can write it as 1 5 if I separate it. You can write it as 5 into 35, or 1 7 if I separate it, 7 into 25. Again, the same way you can write in the reverse order, right? So I write in this form 25 into 7, 35 into 7, 1 into 175. Now again see here, so b is equal to the first number, 35 into 5. Yeah, sorry, my bad. Yes, yes, yes. This is 35 into 5. Yeah. This is fine. No? 25 into 7. 25 into 7 is fine. 35 into 5 is this. Yeah. So if I look again here, now b and c values, if I look into it, so b is straightforward first number. I want it to be a prime number. So 175 is not a prime number, so I'll reject this case. B is 5, so I can take this case. B is 7, I can take it. I can reject 25, I can reject 35, I can reject 1, right? So I'm left with two scenarios over here. So I am getting B value as 5, and I'm getting here 7. Let me say about C also. You are adding 12 to this part. So since I am adding 12 to it, so 35 plus 12, which is 47, and here you are adding 12 to it. So 25 plus 12, which is again 37. Are these two again prime numbers or not? They are prime numbers. So I can say the solutions over here are. So therefore, I can say in this case two solutions is here A is equal to C. So first number and last number are equal. I am having 5, 47, 5, and 7, 37, 7. So here you are getting two solutions. Here you got one solution. So total you are getting three solutions. You understood? This was 22, 1, A, B, C, right? 2 to 197. So therefore, number of solutions is you are asking. Number of solutions are going to be how many, sir? 3. Right? Fine. Sure. You guys can keep trying this PW challengers. I'll give you a couple of questions. You try that meanwhile. I'll discuss for them this. So one question is this. Okay, this again is standard Bernoulli-Spellis equation. You'll say it. We'll discuss how to solve it. This is one question. So you can try meanwhile PW challengers chapter 1. Okay, or page number 29. So page number 29. You look into question number 6, 9, 10. Do in this order. Okay, 6, 9, 10. Then you can try question number 4. This is clear. Express homework only will discuss first. You want this question? Which next question? I need to write it. Achha, this one. We'll discuss this. We'll see first homework question. Yesterday one more homework question was left over, right? So the other homework question what I given extra is solve a plus b plus c plus 2ab plus 2bc plus 2ca
plus 4abc is equal to 2017. And think I told here abc belongs to positive integers, where a, b, c are some positive integers. At the same time, I am saying here a is greater than or equal to b greater than or equal to c. So again, a very big expression, three variables, a number 2017 is there. So what should I try to do here now? Factorize. If I can able to factorize the LHS part, then RHS number I'll split and then I'll try to do it. Or any other idea you're getting? Using cases. So which case you will take? How do you start with case? This case you're saying. But you know, for example, A greater than B greater than C. So there will be infinitely many cases. No? So that is not reducing the number of variables, right? So if I assume A is equal to B equal to C, fine. You will get maybe one. You'll get one equation, okay. But apart from that, you can have a case like A equal to B greater than C. You'll get again one more equation, right? So many combinations will come, right? Think about a factorization of this part. Can you able to factorize it? Are you getting any factors? Think about that. Okay. So again, if I see, for example, I'm having here a 4abc term is there to me, and I can see a 2ab term. I'll do one thing, I'll just take 2ab common from these two. If I take 2ab common, then what is left over here? I'll have 2ab times, I do have one 1 and I do have one 2c, right? And any more thing can I take common? If I take from these two terms again, a term b common, again I'll get 1 plus 2c. So I can add as b into 1 plus 2c. And again I'm having a c 2c plus a. If I take a common from these two terms, will I get 1 plus 2c again? Yeah, I'm getting again another 1 plus 2c term. Right, I'll take a common and I'll add as a into 1 plus 2c. Any other term is left out to me here right now? I think c I have never used, right? So I'll leave c as one. Let me see whether it is going to work or not. Is equal to you're having 2017. So I have clubbed these two terms. I have clubbed 2ab term with 4abc term, and c with c I have kept it as it is. A and 2c I have clubbed it. A and 2ca, these two terms. 2ca. Now maybe I can take 1 plus 2c common, right? If I take 1 plus 2c common, what is left out to me here, sir? It is a plus b plus 2ab, and outside still I have here c is equal to 2017. Add. Okay, even if I add 1, then I'll get C plus 1. No, but here I had 2C plus 1. Good idea. You came very close to it. Yes. If I add C again, the problem is you'll have C also other side. So to get rid of that addition, I want to get rid of that C, addition of C. But I want 2C here. I want 2C. What you can do? Multiply with 2, no. I want 2C, no. Because there's a factor 2C plus 1. That also you can do it. You can add half and then you take minus. Or what you can do is I'll multiply with 2 on both sides. Because the reason is I'm trying to factorize it. I already had a factor 1 plus 2C. I had only a number C over here. So I will multiply with 2 on both sides. If I multiply with 2, then I'll have 2 into 1 plus 2C into A plus B plus 2AB. I'll have here plus 2C is equal to, since I'm multiplying with 2, then I'll have here what? 4034. Now do that thing. You add 1. If I add 1, then I'll have here now 2C plus 1. 4034 plus 1. Now 1 plus 2C I can take common. If I take 1 plus 2C common, then I'll have 1 plus 2C into, okay, I'm taking this 2 also inside. I'll have 2A plus 2B plus 4AB plus 1 is actually what? 4035. Now, can you do anything again for this part? You take 2A common from first and third terms. I'll have 2A into 1 plus 2B. Here also I had 1 plus 2B. If I take 1 plus 2B common, isn't it going to be 2A plus 1 into 2A plus 2B plus 1? Right, again I'll take here 2A common from these two terms, okay? Or you can take 2B common from these two terms. This is 2B into 1 plus 2A. And from first and last term again I'm having 1 plus 2A, right? So if I take 1 plus 2A common, this is going to be 1 plus 2B. That means this entire thing is looking like to me now 1 plus 2A into 1 plus 2B into 1 plus 2C is something in the form 4035. And I know A, B, C are natural numbers, means 2A plus 1, 2B plus 1, 2C plus 1. Which type of numbers are this? If A is any natural number, 2A plus 1 is always going to become what? Odd. So odd number, odd number, odd number. So split 4035 into product of 3 odd numbers. Factorize it and it is product of 3 odd numbers. Right. So I think I can see here 5 is a factor. 3 is also a factor. Sum of these is divisible by 3. So I can add as 3 into. Then how much I'll get, sir? 3 3 is 9, 10 3 is 9, 12 3 5 is 15. Again, if I split 5, 5 6 30, 34, 30, 5 9 is 45, right? Yeah. Is it fine? Three into. Oh, sorry, I made a mistake. Correct. So you'll get here 3 into. You'll be getting here 3 ones 3. Then again, 1 is 3 3 is 9. So what is it when you're dividing 3? What is the remainder left over? Question. 3 times of 1 3 you're getting, 1 5 you're getting. Then 2 6 9. So product of 3 odd numbers, you're also getting product of 3 odd numbers. Now, which odd number I have to compare with it? Because it is given to in the question A is greater than or equal to B is greater than or equal to C, right? So since A is greater than or equal to B is greater than or equal to C, that means I can definitely say now here 2A plus 1 is something in the form to me 269. This gives me the value of A as 268 by 2, which is 1 3 4. Right? If they are not given a greater than equal to b greater than equal to c, if nothing is given, and they are asked you to find number of solutions. So how many solutions I can do for this? How many? If they are not, if nothing is mentioned about if they only mentioned a, b, c are natural numbers. So in that case, you can just write down these three in three factorial ways. 6 ways you can write it out. Okay. So you'll get total 6 solutions. Right. I can write as 3 into 5 into 269 or 3 into 269 into 5. 5 into 3 into 269. So you can express this as product of three numbers in total 6 ways. So each way will give me one solution. So in that case, you'll get total how many solutions? 6 solutions. Okay. Right. Chalo. Before going to this question, let me just give one small definition, which is of Diophantine equations. Right. Is this clear right now? This is right clear, right? Chalo. This is not a medicine name, huh? Okay. So this is basically, see, the problems what you have been solving. So those are these equations only. Like for example, this particular question, it's a Diophantine equation. The meaning of, I mean, what is that is? So he was a mathematician, so Diophantine. So those, the Diophantine equations are equations which has more than two variables and which has integers as solutions. Okay. So this having more than two variables, and I'm trying to calculate integer solutions, right? So this is a Diophantine equation. In how many variables I will say? Three variables. Similarly, the previous question, what we have seen it. This also, if you look into it, equation with more than three variables, and I'm looking for integer solutions. It's a Diophantine equation. This one is also a Diophantine equation. Okay. And yesterday also, what do you solve the questions? Like 1 by x plus 1 by y is equal to 1 by 3, right? 1 by 2027. We have solved actually some questions, right? So those are also comes under the same category, Diophantine equations, isn't it? And just write down that once. These are the equations with more than two variables having integers as solution. Okay, some of the examples of this is, we take for example 7x minus 5y is equal to 4. Okay, so in general, if I don't mention integers, then this is going to have infinitely many solutions. Every value of x will give a value of y, right? So whenever integral solutions are there, so that is what comes under Diophantine equation category. So this is one example. You can write multiple examples, okay? Or maybe I can write it as the next question what I was about to give you. X square minus 2y square is equal to 1 is also a Diophantine equation. So these are Diophantine equations in how many variables? Two variables. So this will be calling it as linear Diophantine equation. Linear Diophantine equation in two variables. Okay. Or if I say x square minus 2y square is equal to minus 1, this is one Diophantine equation. Okay, you need not have two variables, you can also have three variables. So you can have like Pythagorean triplet, x square plus y square is equal to z square. This also you can make it as a Diophantine equation only. So equations with more than two variables and where you are having integral solutions, those falls under this category. Okay, if I ask you how many integral solutions will be there for this equation, or how many natural numbers are there? Forget about integers. How many positive integral solutions are there? 7x minus 5y is equal to 4. How many I'll get? Infinitely many, right? Is it required like every equation will have infinitely many solutions again? It depends upon the equations category, right? Sure. Now we'll, since I already given this as a question, first we'll discuss about this, then we'll discuss about linear differential equation. How do I solve it? Because since whenever it is having infinitely many solutions, if it's required like you have to write the solution in general format. Okay, general, all the infinitely many solutions will be there in one particular general form. So general form, if you're able to write, it is then. Okay. Or let me say, for example, before this question, if I give you one more question, okay. For example, if I asked you to solve x square minus 625 y square is equal to 1. Xy belongs to again integers. Okay, I am saying here x comma y belongs to integers. Okay, so these type are called simplest equations. Okay, so again, because since this is a perfect square, I can easily factorize it, and the solution I can say is, I mean, I'll get as x plus 25y into x minus 25y is equal to 1. You are having it. So 1, there is only one way of splitting into product of two integers. It is either I can add as 1 into 1, or I can add as what? Minus 1 into minus 1. No other way. Now I can equate both of these to ones or both of them to minus ones. If I am equating both of them to ones, x plus 25y, x minus 25y. If I am equating both of them to ones, you will get the answer as, you add it, you will get 2x is 2. I will get x as 1, y is 0. If I am equating both of them to minus ones, if I equate both of them to minus ones, x plus 25y is equal to minus 1, x minus 25y is equal to minus 1. Again, here I will be getting x as minus 1, y as 0. So I am getting two solutions over here. So x comma y are what I can say plus or minus 1 comma 0. I will not get any other solution. Right? See, as long as you are having a perfect square over here, if you are having 36y square, then again I'll have x plus 36y into x minus 36y. So again we'll get the same thing, right? So these type of equations are called Bernoulli's Paris equations. Okay. So if you're having a perfect square over here, that value is always going to give you, the solution is going to be plus or minus 1 comma 0. But Bernoulli-Paris equations are those where you don't have a perfect square. Like x square minus 2y square is 1. I have to solve it. Or x square minus 5y square is equal to 1. You are trying to solve that. Got it? So if you are getting, if you want to, you can make a note and write down. So for all the equations, for x square minus ky square is equal to 1, where k is a perfect square. K is a perfect square. The solution is always plus or minus 1 comma 0. Right? Now same thing, now we'll see if it's x square minus 2y square equal to 1. Now if I factor, I'll get a irrational term, x plus root 2y into x minus root 2y. Right? Can I equate x plus root 2y to 1 here? Yeah. Unless if y becomes 0, then it is possible, right? So that is not like, although you will get here 1 comma 0 as one solution, so that is not the only solution, right? You might get some other solutions also. That we have to figure it out now here. Can you figure out any other solution apart from 1 comma 0? If you take x as 3, 9 comma 2, there is also a solution. Plus or minus 3 comma plus or minus 2, plus or minus 1 comma 0. Apart from that, 3 comma 2, another solution. 17 comma 12. Yeah. So like that, you'll get infinitely many solutions. Now we have to figure it out. How do I write the general form of the solutions? That we will look at it. So whenever you're getting these type of equations, so firstly what you do is first find any one solution. Find any one solution, okay? So I'll try to find any one solution. What I can do, since the number 1 is there, I'll take it to LHS part. So x square minus 1 is equal to, still you're having 2y square, right? Or one solution you can try to find by hit and trial also. That is also fine. Okay. Just try to find one solution by hit and trial. Because if I'm trying to factorize here, I can still write as x plus 1 into x minus 1. Okay, so I can write as maybe something like 2 into y square. Okay, so I can equate x plus 1 to 2. That will give me x as 1. So if x is 1, 2 into 0 is equal to 2 into 0. That is going to work out, right? So that is going to give me one solution x comma y as, I would say 1 comma 0. Or you can use hit and trial method and find one solution. After finding one solution, what I will try to do is, see, there is a small concept of binomial theorem. Let me explain it once. I think already I given you binomial theorem in the first lecture, right? How does a plus b whole power n formula looks like? Did we give it? Binomial theorem formula. I have not given it. Okay, or fine. For that matter, for example, let me say if I have uh, a plus root 2b whole to the power n, okay, where n is some natural number, okay, n belongs to natural number. If this entire thing, okay, for example, if I take a plus root 2b power 1, if I take simply a plus root 2b power 1, or take anything like this, 2 plus 3 root 2, you take it. If I am squaring it, so what type of number I'll get? If I look into it, I'll have here 4 plus 3 square 9. 9 into 2 is again 18. 2a beta, if I look into it, what is 2a beta going to be there? You know, 2 into 2, 4, 4 into 3, 12 root 2. This will give me something like here, no, 22 plus 12 root 2, right? If I take power 3, means again I am getting here, there is a integer part, there is a irrational part in this number. The integer part is some number, but the irrational part is always having what? Root 2. If I take power 3, so again which format I will get? Can I say I will get something in the form a integer part plus root 2 times of some number, can I say? So whenever I'm having something in the form a plus root 2b whole power n, okay, so it means I can always say this is going to come down to something in the form, I can say uh, something like x1 plus root 2 y1. Okay, you can write, if this is a scenario, if instead of this, if I'm trying to do minus, no, a minus root 2b whole to the power n. So this is what will I get here now? It is something like a identity only to, it is like a formula. I'm replacing root 2 with minus root 2. If I replace root 2 with minus root 2, what I'll get here, sir? I'll get x1 minus root 2 y1. Is it fine? Or you can simply take an example like this. Okay, just take a simple scenario. If I have 1 plus root 2 whole square, so I'll get 1 plus root 2 whole square as what, sir? 3 plus 2 root 2. If I'm having now 1 minus root 2 whole square, if I'm simplifying it, a plus b is 3. Minus 2ab is what? Minus 2 root 2. Similarly, if I have 1 plus root 2 whole cube, if I'm trying to simplify it, I apply a plus b whole cube formula. Then a cube plus b cube. So b cube is what here, sir? 2 root 2 plus 3a square b. So 3a square b is 3 into root 2 plus 3ab square, which is again 2. So 6 plus 1, you are getting 7. 7 plus 5 root 2, you are getting, right? So I'll get 7 plus 5 root, right? So again, I'm getting a rational part, irrational part too. In the irrational part, always I'm getting what? Root 2. That's what I'm trying to say it. So for example, if I take now 1 minus root 2 whole cube, so this again going to give me what, sir? Something like 7 minus 5 root 2 it will give me. Because it's almost like in the above thing, I'm replacing root 2 with minus root 2. Here only it gets replaced. Okay. So if you want, you can write here, if n belongs to natural numbers, or if a, b, n, everything, I'm taking it as a, b, n belongs to natural numbers. Then always what you'll have is, this will be something in the form x1 plus root 2 y1. This is going to be in the form x1 minus root 2 y1. Just make a note and write down. Make a note like this. And for this question, first find one solution by hit and trail. Okay, so that is what is this. So I'm trying to find one solution. That one solution, first of all, I got it is this. Hmm. You're trying to factor it as x plus root 2y. X minus root 2y. You're trying to say you're getting 1. That's what I'm trying to do here is now, because can I equate x plus root 2y to 1? I can't, because if xy belongs to integers, x plus root 2y will be, it is going to be irrational number, provided if y is not equal to 0, it's always going to be irrational number, right? If y is 0, it is going to be again an integer. Now what I'll do is I'll just take power n on both sides. Okay, if I'm just trying to raise it to the power n, see, this is a solution, right? This solution I am just assuming it is x1 y1. Okay, so x1 y1 is solution which is satisfying it. It's a number already which is satisfying it. Okay, now if I'm just trying to say, since x1 y1 satisfies it, so I'll do one thing. I'll add x1 plus root 2 y1 into x1 minus root 2 y1 is always what? 1. If I raise it to some higher power, I'm just raising it to some higher powers, means I can always write now here x1 plus root 2 y1 whole to the power n into x1 minus root 2 y1 whole to the power n. Okay, so what I'll do is, I don't know what is the value of x1 plus root 2 y1, right? So because x1 plus root 2 y1 whole to the power n when I'm looking at it, so that is going to give me, or let me write it separately over here. So I'm just assuming here now, let x1 plus root 2 y1 is equal to something like a plus root 2b whole to the power n. If this is this, then what is x1 minus root 2 y1 whole to the power n going to give you? It will be definitely a minus root 2b, right? Now I'll do one thing. So what I'll do is I'll just take this part, because x1 y1 is this original one solution by hit and trial method. Okay. So once you're getting that, if I just raise this to this power n on both sides, if I take power n on both sides, then what I'll get, sir? I'll have x1 plus root 2 y1 whole to the power n into, again what I'll have again x1 minus root 2 y1 whole to the power n is equal to, indirectly you're getting 1 power n. 1 power n is always what? 1, right? Is it fine? Now what is x1 plus root 2 y1, sir? It is looking like what to me now here? A plus root 2b into a minus root 2b. So this will give me again which format now? A plus root 2b into a minus root 2b is equal to 1. Is it exactly same as the original equation only or not? A plus root 2b into a minus root 2b. If I multiply it, what I'll get a square minus 2b square is equal to 1. Now what are a and b here now? What are a and b? They are coefficients of x1 plus root 2 y1 whole to the power n. So how do I find that? For example, here I am getting x1 as 1 and I have here now y1 as 0, right? Right. So you just take it whole to the power any natural number you try to, you can keep trying to do it. Okay, we'll do it once. Is it understood here? Because the solution first, initial solution itself one solution. Acha. Take a solution in such a way, like, because if y is 0, no, always this part will become 0. Okay, so I'll take one more solution where y is not equal to 0. So can you say one more solution where y is not equal to 0? I can take 3 comma 2, that is fine, right? So let me take here a 3 comma 2 solution. 3 square 9, 9 minus 8 is 1. Okay, because if y becomes 0, this part you can always, you will not able to calculate it. Now I know here one solution is 3 plus, if I take 3 plus 2 root 2 whole square, for example I am saying, I am taking x1 as y, so 3 plus root 2 into 2. If I solve it, if I do whole square, then what I'll get, sir, a plus b whole square applied, I'll get a square plus b square. So a square is to you 9, b square is 4 into 2. I'll get 8 plus 2ab, 2 into 3 6, 6 into 2 12, 12 root 2. Means I'll get some value as 17 plus 12 root 2. Right? So similarly, if I take 3 plus 2 root 2 whole power 1, it is already 3 plus 2 root 2. The coefficients of the I mean the real, not the real part, I would say the integer part in this and the root 2 coefficient, that itself are the solutions here, right? Because if you see basically here, when I am expanding it, I am getting an integer number, and for root 2 the coefficient is y. So what are AB becoming indirectly? So AB itself is solution of the original equation or not? Can I say now here AB itself is solution of the original equation? AB is solution of given equation. Can you think in that way? I am just trying to figure out how do I get AB, because already I know one value of x1 y1 is 3 comma 2. If one value is 3 comma 2, then I'll have 3 plus 2 root 2 whole power 1. If I take 3 plus 2 root 2 whole power 1, I'll get 3 plus 2 root 2. That means one solution is what I can say with this. So 3 comma 2 is a solution. Now with this, when I simplify it, I'm getting it as what? 17 comma 12. So 17 comma 12 is also a solution. Alright, if I want to figure out one more solution, what I can write? I can write 3 plus root 2 2 whole cube. Okay, so try to do a plus b whole cube. See how much I'll get here now. A cube is 3 cube 27. B cube, if you look into it, 2 cube 8 root 2 whole cube again, which is 2 root 2 plus 3 a square b. So 3 times of what is a square, sir, 3 square into root 2 2 plus 3 a b square. So 3 3 b square, if I look at it, is going to be 2 into 2 square, right? If I simplify this again, 3 a b square we written, right? Yeah, it is 2 into 2 square. Yeah. So you are getting here 2 square 4, 4 2 is 8, 8 is 24, 24 is 72. So this is 72. And here you are having already 27. That means I am getting 99. I say that. And this, if you simplify it, how much I am getting here, sir? It is 14 root 2. And here you are getting 3 square 9. 9 3 is 27, 27 to 54. So 4 plus 4, 8, 68 root 2. So what is another solution I can say here? So one more solution is how much? 78 is it? Check it once. Actually, it is 16, right? Yeah. 27 to 54, 54 plus 16, 70. So one more solution you're getting is 99 comma 70. So 99 comma 70 is also a solution. So like this, you'll get infinitely many solutions. We'll see how do I write the infinitely many solutions in a generalized format. Okay, you understood what I done? So because simple logic, first try to find one solution by hit and trial method. Once you find one solution by hit and trial method, I am assuming that solution as x1 y1. If I am factorizing this is how you'll get it, right? Now if I take power n on both sides, now in using binomial theorem, what you can say is x1 plus root 2 y1 whole power n. If this is a plus root 2b, when you're taking minus, you will get a minus root 2b. So this basically gives me same equation, a square minus 2b square is equal to 1. Means indirectly what is the meaning? A, B are the solutions. What are A, B here, sir? You expand this, you will get the value of A, B, right? Are you getting it? Now if I want to write a generalized solution, so how do I write a generalized solution? If I want to find the value of A from these two equations, how do I find? How do I find value of A from these two equations? I want to write because see, when I'm writing solutions, there are infinitely many solutions, right? If there are infinitely many solutions, if I write it in a generalized way, it is going to be helpful to you because I can't list all the solutions. I will write in some general format. General format means, for example, AP, if you look into it, there's an nth term of AP formula, right? So in the same way, I will write the general format. So if I want to find A, because I know A is the solution, A comma B are the solutions of the given question, right? So how do I get value of A from these two equations? From these two equations, how do I get the value of A? Add it, then root 2B gets cancelled. I'll get the value of A or not, right? Hmm? Hmm. By 2. You are adding these two and dividing by 2. That's all. Hmm. So when I want to write a generalized solution, what you can say is now here. So to write a general solution, let me take a copy. Okay, so general solution is here now. So from this, what I can conclude? So A looks like to you what, sir? A is equal to x1 plus root 2 y1 whole to the power n plus x1 minus root 2 y1 whole to the power n divided by 2. And what is x1 y1 here again? It is one solution by hit and trial method. Okay, to me that solution here I am taking as 3 comma 2. That means I can say it is something in the form to me now 3 plus 2 root 2 whole to the power n plus 3 minus 2 root 2 whole to the power n by 2. This is what is generalized format. You take any different values of n, that will give different equations. Similarly, b, if I want to find out, I'll subtract these two equations and divide by 2, right? So b is something which is going to give you as x1 plus root 2 y1 whole to the power n minus of x1 minus root 2 y1 whole to the power n. I'm getting here 2 root 2. If I am replacing that solution here, I'll have 3 plus 2 root 2 whole power n minus of 3 minus 2 root 2 whole to the power n divided by 2 root 2, where n is some natural number. So these are what are called general solutions to you. General format of the solutions. Right, see, I have taken here x1 y1 as 3 comma 2. You can take some other solution also because we have figured out there are many solutions, right? You can take x1 minus 17 comma 12 also. That is also still fine. 17 comma 12. Anything. Did you got this? Which one should? You try the same question now. Instead of 1, take it as minus 1. Take it as minus 1 and try it once. So you can take next slide also. Okay. These are some particular solutions. This is what we'll call them as particular solutions. Or if you're replacing here 1 with, I mean, n if I replace with 0, no? 3 plus 2 root 2 whole power 0 is 1. Right, you can see it. Even if you replace with 0, I'll get here 3 plus 2 root 2 whole to the power 0 is 1. So, can I write down that 1 as 1 plus 0 root 2? Let's say again one more solution is 1 comma 0 is also becoming one solution, right? Yeah, 0 isn't a natural number, but binomial theorem when we discuss it, so you'll be discussing it for higher powers, natural numbers. But even if you take n as 0, that is also going to work out. This will give you now here one more solution is 1 comma 0. Hmm. Yeah. Okay, if the question is something in this way now here, solve x square minus 2y square is equal to minus 1. Now, can you write the general solution of this? Use the same format and let us write that part. Can you figure out one solution by hit and trial right now? 1 comma 1, yeah. So figure out one solution by hit and trial. So 1 comma 1 is one solution by hit and trial. Now once I got 1 comma 1 as one solution by hit and trial, so I'll write as 1 plus x1 plus, I mean, if x1 y1 is solution to you by hit and trial, and if I see it, it is x plus root 2y into x minus root 2y, right? So I'll write as 1 plus root 2 whole to the power n, right? Similar format. 1 plus root 2, yeah, you have to make n as odd. That's it. So x1 plus root 2 y1 whole to the power n. If I assume it as again a plus ib, sorry, why I'm getting I here, my bad, sir. A plus root 2b, and I'll take the other scenario here, x1 minus root 2 y1 whole to the power n will be definitely coming in the form of a minus root 2b. Okay, and if you look into it, if I take simply power n on both sides of this equation, so I can write it as now x1 plus root 2 y1 power n into x1 minus root 2 y1 whole to the power n is actually looking like minus 1. Now x1 plus root 2 y1, so it's minus 1 or minus 1 power n, minus 1 whole power n I can say it. Now x1 plus root 2 y1 is a plus root 2b, this is a minus root 2b. That means I am getting here now a plus root 2b into a minus root 2b is equal to minus 1 whole to the power n. So this will give me what, sir? A square minus 2b square is equal to minus 1 whole power n. So this is exactly going to match with the original equation if n is actually what? Odd. So if n is odd, then only I can say a square minus 2b square is equal to minus 1, and I will have a comma b as solution of, will be solutions. And if I want to write down that a comma b, so how do I write that a comma b in general format right now? So I can say a value is something in the form to me. Add these two and divide with 2, right? So a looks like, you know, here x1 plus root 2 y1 whole to the power n plus x1 minus root 2 y1 whole to the power n divided by 2, where n belongs to actually what here? No, n is odd. Then only it is going to happen. Similarly, you can say b value is going to be x1 plus root 2 y. Yeah, you have to replace x1 with 1 and y1 with 1. Okay, so to me here x1 and y1 are 1. You can replace it. So I can write it as 1 plus root 2 whole to the power n. And if I try to figure out value of b, so just subtract it. I'll get again here now 1 plus root 2 whole power n minus of 1 minus root 2 whole power n by you are having 2 root 2. And if you want to figure out another solution, just replace n with 2, n with 3. You keep inputting it, you'll get different solutions. You understood? Ah, okay, that's fine. Ninth one, what? What about sixth one? Okay. Seventh? That was eight. They're not given. Okay, okay. Got it. Right. So there are infinitely many solutions. So this is what the general format is looking like. So replace different values of n, but I have to replace only odd values. For next value, I will replace n with 3, n with 5, like that. Okay. So these equations are actually called Bernoulli-Paris equations. If you don't have here perfect square, Bernoulli-Paris equations. Okay, so we'll discuss about the other format in tomorrow's lecture, and we'll see some more questions in tomorrow's class. Other format means Diophantine equation in linear format. Okay, and some more based on this we'll look in tomorrow's class. Okay. Meanwhile, what you can do is I'll try to give some questions from module. You can try those questions. Give me one module. I think DPP one I asked you to solve previously only, right? DPP one. So DPP one is based on factorization and all that. There are 20 questions in that. 1 to 12, right? Yeah. So you can solve the remaining questions then. Question number 13 to 20 in this. These will be straightforward questions. Then Weaver method of solving inequalities, you are not aware, no? We'll start it next week. You guys are aware, right? Weaver method of solving inequalities, right? So those who know, you start solving it, okay? Weaver method of solving it. If you don't know, it's fine. We'll anyhow start it in the next week. This is based on Weaver technique. Weaver method. If you know, then only you start it, okay? Else don't start it. So DPP2, question number 1 to I would say question number 10 or up to question number 12 you can do it. And then in trouble exercise, Trouble exercise. Question number 1 to 5. Q1 to Q5. $29, $30, $32, $33. $42 to $47. $42 to $47. Okay, and the question is what I given in challenges right now. You can try that. Okay, so PW challengers. Question number 6, 7, 9, 10. So if you want, you can try question number 4, 11 also. Right. So many of these questions are like Vevikar method. Anjana, you can skip it right now. It's fine. But these questions, whatever you're able to solve it, try to do it. Okay. Right. Thank you.